Hiya girls, this is an introduction to Surds. Pardon me if some of the drawings are a bit dodgy, I don't have a stylus. So, here we go. What I'm wanting to show you in this video is just an introduction, so we're going to try and understand what Surds are. We're going to learn to simplify Surds, and we're going to learn how to count Surds. There's a few more things to Surds, but they can come in other videos. Here is the core understandings we're after. So, before we define what a surd is, let's look at squared numbers. We want to know as many of these off by heart as possible, and some of you will know many of them straight away: square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81. There's our first 9. So that would be 1, that would be 2, that would be 3, and so on and so on. I would advise that we try and get up to the square root of 225. That is 15. It's just nice to have those tucked under your belt. Use your calculator to find out what they are, because we want to be able to recognize them swiftly, and you'll see why a bit later on. These are not surds, these are squared numbers. Now, what happens when you square root a number? Alright, so let's draw, say, 9. Here is a square with an area of 9, and just like we saw before, when we take the square root, we're really, one could say, it's like we're finding the length of the side of a square with a certain area. So for instance, if this is a square with an area of 9, when we take the square root, its area is, the square root is 3, because that's the same as the length of the side. Fair enough. But what if, when we square root, we don't get a nice neat answer? What if I said, instead of having a square with an area of 9, I had a square with an area of 10? And when you take the square root, when you find the length of the side of this area, the square with an area of 10, we get this amount here, which is just a bit more than the square root of 9. And how much is it? Well, square root of 10, in this form, in surd form, is exact. When you use your calculator to find the square root of 10, it gives you an approximation. Here's our approximation for the square root of 10. 3.162377, yeah, you can read. So there's our approximation, 3.16, and here is our exact form. So when you're after a surd in exact form, you leave it like that. Unless you can simplify it, you leave it like that. So surds are not squared numbers, because squared numbers give us a nice neat whole number answer, or even a terminating decimal answer, but we're not going to deal with that today. Whereas surds give us this ugly string of digits with no end. Now on this calculator display it has an end, but if this calculator display could go forever, so would our digits. So surds are about working with exact values. So let's have a look at some numbers that become surds. Of course, we know that we've got some squared numbers in here. We don't really need those squared numbers, so let's get rid of, say, those ones we've got so far. And here we've got the leftover numbers. All of these, if you take the square root of them, give ugly answers that are non-repeating and non-terminating if you found them on your calculator. The decimals would go on forever, at least as far as we know, and there would be no discernible pattern, and there would be no repeating pattern as far as we know. Alright, so what can we do with them? Well, if it's a prime, you can't do anything with it. That's what it is. And if it's a prime, you just leave it alone. If it's not prime, we need to see if one of its factors is a squared number. So let's have a look at what that looks like. Here we have 3 things that are definitely surds, because they're not our squared numbers, but we may be able to simplify them. So, change colour to black. There we go. If you have a look at this number here, this 8, if I were to write it out like this, there's a squared number hiding in the 8 as a factor. This is actually 4 times 2. Now there's one of our squared numbers. What we're allowed to do is split it into two things. So it's square root of 4 times the square root of 2. Now this fellow turns into a 2 because the square root of 4 is 2. And we've got two lots of the square root of 2, which you just leave like that. 2 root 2. You've got 2 of these root 2's. And this is how you simplify surds. You analyse the number underneath this wonderful thing here. This wonderful thing here has the best name ever. This wonderful thing here is called a radical. That's actually its technical term, a radical. Radical. Did I leave an... Yeah, how about I put an I in too? There we go, radical. Alright, so what we want to do is analyse this number here, because there may be... Okay, sure, I did on purpose. There is a squared number hiding in there, so we need to simplify it by saying this is the same as the square root of 9 times 3. Now we can split it up. Square root of 9 times the square root of 3 is 3 lots of root 3, because that becomes 3. Alright, so some of you, if you get a real handle on it, you might find that you don't have to do all of this working. You might see that 48 is 3 lots of 16. 16 is a squared number, so we could rewrite this saying we've got 16 hiding in there. When the 16 comes out, it becomes square root of 16 is 4, and what's left behind on the inside is 3. Just to explain again, this is the same as square root of 16 times 3, but all I've done is take the 16 out the front, and as it leaves the radical it gets square rooted and becomes 4. Alright, so that's how you simplify surds. And lastly, for this video, what do we do if we want to simplify... Oh, sorry, second lastly, because this is a hard one. I wanted to show you one hard one, so I forgot about that. Okay, so square root of 588. What could we do if it looked really ugly and I couldn't see one of my squared numbers hiding in there? Well, if you're asked to simplify, then there's going to be a squared number hiding in there. Unless they're being really cheeky, they want you to find the squared numbers hiding in there. So let's have a look at this. And we can analyse it by throw it off to the side and try factorising it. You remember factor trees, weren't they fun? We're going to use one here and use some of our tricks that we know from multiplication. Because that ends in 88, and I know that 88 is for my 4 times tables, this whole number must be divisible by 4. And so I grab my calculator, go 4 into 488, and I discover it is 4 lots of, now come on, brain, 147. Okay, so I've found 2 factors, and look, one of them is a squared number. So is this just 4 lots of 147? Well, let's check. Let's see if we can take this any further. Having a look at this number here to see if it's a prime, I add the digits together. 1 plus 4 plus 7. 1 plus 4 plus 7 is 12. 12 is from my 3 times tables. That's another little trick. So it must be 3 times something. Now if you don't know what I'm talking about, you can request me to explain what I just did. That's a little trick that you can use with your 3 times tables. This is actually 3 times 49. Oh, and look, there is another, let's bring that 4 down. There is another one of our squared numbers. So there are 2 squared numbers hiding in this big number. So whenever you have more than one squared number hiding, you can combine them together. 4 times 49 is 196, and you might ask, why did I do that? Because whenever you've got more than one squared number, you can combine those together and find that this is a bigger squared number. The 3 is still there, don't forget the 3. And at any line, and this is remembering how, what are these called again? Tree diagrams work. Every line should be able to multiply back together to make the top number up here. And you'll find that 3 times 196 is still 588. And 196 is the 14 squared. So Here's our 588, which is really 196 times 3. And we're going to simplify it by bringing that out. And as it comes out, we can square root it. It becomes 14 lots of root 3. Okay, lastly, I promise it is the last thing. Okay, how do we count surds? Well, in this first example up the top, I've got 4 lots of this root 2, and I've got 2 lots of this root 2. And just like in algebra, we can collect like terms. In surds, we collect like surds. So if I've got 4 of these root 2's and I've got 2 of these root 2's, then altogether I've got 6 of these root 2's. Now this 5 root 3 can't combine with anything because there's no other root 3's around, so it just comes down. Now let's combine this all together, both simplifying surds and counting surds in this next question. This next question here. Here we have 7 lots of root 32 minus 8 lots of root 3 plus 3 lots of root 18 plus 5 lots of root 12. Now, when you take, I'm just clicking down, when you take one look at that, you might say, well, root 32's, root 3's, root 18's, root 12's, none of them can go together. But what if we simplified, where we could, some of these surds? So I can see that 7 lots of root 32, or 32, is the same as 4 lots of 8, or even 16 lots of 2. So 16 is a squared number, 16 times 2. I can simplify that one too. That 16 can come out. Now when it comes out, I end up with this. 7 times the 16 comes out and becomes 4. And all of that is being multiplied by root 2. So really all we're looking at so far is this initial 7 root 32. We're just trying to simplify that. 7 times 4 is 28. I've got 28 of these root 2's. Just all out of this term here. Now, root 3 can't be simplified any further, so we're just going to take it all the way down to the bottom here and say we're minusing 8 lots of root 3. Let's have a look at this one here then. 3 lots of root 18. Well, 18 is 2 lots of 9, or 9 lots of 2. So I could write that as, I'll just put it on this line for now, plus 3 lots of root 9 times 2, which is plus 3 lots of 3 root 2, because that 9 comes out, and as it comes out of the radical, it becomes a 3. I've got 3 times 3 times root 2. So 3 times 3 is 9. 9 lots of these root 2. Oh, we can now see that I've got a root 2 at the first term and root 2 in the third term. But lastly, let's have a look at this one. 5 lots of root 12. So I've got 5 lots of, now 12 is 4 times 3. There's our squared number hiding in there. So as it comes out, we will have 5 lots of 2, square roots on the way out, times root 3, which is 10 root 3. Alright, so now that I've simplified all these terms, I look for the like terms, look for the like surds. I've got 28 of them, another 9 of them. Adding 28 to 9 gives me, whatever the heck that is, 37. Sorry if I'm being a bit slow. I've got 37 of these root 2's. And how many root 3's do I have? I've got negative 8 root 3's. Positive 10 root 3's makes 2 root 3's. Now, it's a bit difficult where I'm at the moment to set you textbook work, but I can set work on MathSpace that will get you going on Surds, and as soon as I can I'll upload some stuff onto Moodle as well. Cheers girls, and good luck.